Okay, so this is example 2, and we're going to write the complex number z is equal to radical 3 plus I in the trig form. Okay, so let's see how we're going to do this. Well, the formula for us tells us that r is equal to radical 3 squared plus 1 squared, which is going to be radical 3 times radical 3 is itself, plus 1 is radical 4, which is 2. Okay, so we're good right there. Now, this also is, now we know again it's going to be a plus bi, and it looks like b is equal to 1 here. B is equal to 1. Okay, so we're going to look at that right here. The step 2 is going to be tangent of theta is going to be b over a, and b is going to be 1, and a is radical 3. So that looks like it's going to be at look at your trig unit circle. Tangent looks like it's going to be pi over 3. Pi over 6, I'm sorry, pi over 6 right there. So that's going to be pi over 6, because pi over 6 cosine is radical 3 over 2, and sine is 1/2. So if you take the sine of that, you get tangent of that is sine over cosine. So you do get 1 and radical 3. Of course, the denominator is not rationalized, but for this purpose, it's okay. So now, so what do we do with this information? Well, we're going to see that although the value information we know is that a is positive and b is positive, so it looks like it's going to be on the first quadrant, positive, right? So it looks like the answer is going to be on the first Q1, first quadrant, quadrant 1. Okay, positive. So now let's try to put everything put together. The formula that we learned about the z in the trigonometric form of a complex number was given to us by z is equal to r cosine theta plus I sine theta. And we know that the r was 2, so we get that here. So we're going to come over here, and we also know that theta, we found that theta to be pi over 6. Theta is pi over 6. Okay, so that means that we're going to substitute pi over 6 here, and then we have the imaginary sine of pi over 6 right there. Okay, so we know that that's going to be, it's like that's going to be our answer, and that's how you're going to do that problem right there. Okay, and if you were to graph this, okay, that's all we have to do, that's all we can do. So if you were to graph this, it's going to look like, let's see how it's going to look like if you graph it. It's going to graph it. It seems like it's going to be radical 3 is going to be between 1 and 2. Okay, and then we have 1 right there, so it's 1, 1 and 2 right there, which composes of the imaginary numbers, the imaginary axes. Okay, so we got we got the reals right there. So it looks like this answer right here is going to be radical 3, approximately radical 3, which is closer to between 1 and 2. And it's going to be right over here where the 1 is. So it's going to be right here somewhere for z. Z is equal to 3 radical 3 plus I. And that's the finale for the example 2, and I hope that was very helpful.